second. Just got it. It hasn't stopped their video on, sir. That's why.
Good morning.
Good morning, sir.
Good
Am I
morning.
audible?
Good morning, sir.
Yes, sir.
So can you
Yes.
turn on your videos? Otherwise, it appears a completely black screen and I don't find anyone who will be listening to me. Okay, that's good. Okay, fine. So we will continue with the discussion that we had in our previous session, and I hope you have gone through the files that I already sent to you, and maybe based on that you have revised the concept. So in our previous session we discussed about the aspects of the process selection, the different types of the manufacturing systems, then some of the aspects of the layout planning, the different types of layout, that is the process layout or the product layout, fixed position layout, then the group technology layouts, which are very common, you will find in many manufacturing industries, and even some of these concepts even can be applied to maybe the office layouts or maybe to any service facility layout. We also looked at the approach on how to design a process layout. In that, we looked at the systematic layout planning approach, wherein we have applied the steps of the systematic layout planning, and based on that, how we can come up with the block plan based on the relationship between the different we can say departments or sections that exist in the organization. We also looked at the product layout design, wherein the facilities are arranged along the line, so that the processing operation, it follows a fixed sequence. So in that case, we need to use the kind of a product layout wherein we can use the line balancing technique, or by which we can uh, uh, club the different activities to form the workstation, so that whenever the product will move through that particular workstation, and the product will be finished at each stage, so that finally the product is rolled out of the final station. And so these are the things that we discussed in our previous session. Is there anything, any doubt or anything which is not clearly related to this? So is the concept on the how do we group the activities to form the workstation based on the different techniques that we discussed in our previous session? I hope this is clear.
Yes, sir. Yes, sir.
So related to the formation of the workstation, we discussed about the two techniques, wherein in one technique we list or we group the activities based on their elemental times. So, and in second, we try to calculate or estimate first the rank positional weight, and based on that we allocate the activities to form the workstation. So we discussed about this example, and maybe based on that, we have looked at how we can group the activity. It was a simple example. So is this concept on how do we estimate the rank positional weight is clear, and based on that, how do we allocate the activities to form the workstation? Okay. So if there are no as such difficulties related to it, we'll move ahead and so today we'll discuss about the group technology layout and also about how we can improve the layout. So we discussed in our previous session about the process type of layout, but then based on the systematic layout procedure or any other design technique that you have used, once you have formed the initial layout, how we can improve that layout, maybe based on the pairwise exchange of the different departments. So these two things we will discuss it today, and then we will also look at the locational aspect of the facilities, and based on that we will also discuss about the case that I have already shared with you on the Google Classroom. I hope all of you have gone through that case, and maybe based on that we will discuss how we can analyze the case and look at how we can solve that particular problem which is faced by the company for the facility location. Okay, so group technology is a kind of situation wherein we can group the different machine based on the formation of the part families. Okay, so a part family is nothing but a concept which involves that whenever there is some kind of a similarity, it may be in similarity in terms of the shape, it may be the similarity in terms of the processing activities. So if such kind of similarity that exists between the different components or the different parts, we can combine those parts and we can form a part family. So the objective is of subdividing the machines and components into the subgroups. Okay, so whatever the products or the component they are having a similarity, those can be combined and they can be formed as a part of part family, and then whatever the machines that are required to process those part family, we can form a group of those particular machines so that a particular group of machines will be allocated to that particular part family. So each subgroup of the component form a part family and is endowed with a corresponding subgroup of machines. So a group of machines will be working, or they will be utilized for processing those particular components or parts. So we can see that there are a number of techniques which are available to form the cell or a group of machines. So we can see that either a production flow analysis, or there are a number of clustering analysis techniques are also available, a graph theory, or there are so many, because whenever you are looking at any formation of any part family and the group of machines, or when you are looking at a group technology kind of layout wherein you are looking at forming a cells.
Sir, sir, can you please tell some examples of GT layout, sir?
Yeah. That's what I wanted to show. So like this, we can form the group of machines that will process the particular part family. So you will find that in in many machine shops or in many industries, they try to form a part family based on the similarity of the different processing activities which are required. For example, let's say there are certain part families or there are certain components in any shop which requires, let's say, these 4 machines. Okay, so lathe machine, milling machine, drilling and grinding machine. So depending on what kind of processing is required in those particular parts, and based on that, what machines are going to process the part, we can form these cells. So this is nothing but the different cells. And then there will be operators who will be operating on these particular cells. So you can see that nowadays, because of the CNC machines and all, the job of the operator, it remains only of the loading and unloading. Otherwise, rest of the processing parameters which are involved in any processing, those being taken care by the machines or the programs itself. So in such situation where we can see that there exists a similarity of the processing, and maybe based on certain kind of characteristics by which we can include them as a part of a family. So a family or a part family is nothing but they will have certain characteristics of similarity which will bring them into some kind of a situation wherein they can be clubbed as a part of the part family. And whatever machines those will be required to process those particular parts, they can be formed as a part of a cell, and then different cells can be formed so that those particular cells will be dedicated for those particular part families. So if we have a situation like this, then we can have number of techniques by which we can club or we can form different part families, and based on that we can decide that which machines will be processing the particular part families. So we'll look at this one example wherein,
sir, here can we say that each individual cell is working as an assembly line for individual component?
it depends. It may be a processing or it may be even a machining. If, for example, if certain kind of sub-assembly is to be formed, okay, so in that particular situation where there are similar sub-assemblies that needs to be manufactured, so there exists a small, we can say, deviation or change in the sub-assemblies of those particular products. So in that case also we can form some kind of a cell, and maybe we can utilize that particular grip technology or group layout for assembling those particular sub-assemblies. So the main point here is that there has to be a characteristics of similarity, so that whatever the facilities that are being involved in that particular cell, those should be utilized to those particular product or the component.
Is it similar to plant in plants, sir? Is the group technology?
Yes, to some extent we can say. Okay, so we can see here a kind of a situation wherein we can see that there are number of components, and here it represents which machine will process these components. For example, the component 1, 2, 3, 4, and 5, and 7 to 10 will be processed on machine 1. Similarly, the machine 2 will process 2, 3, 4, so on and so forth. So here the number 1, it represents the yes decision for that particular component. So this type of configuration that we call it as machine component or parts.
Sir, it is just sir, it is just like that. We have different shops in an industry, like press shop, weld shop, paint shop, like this, or this we can correlate with that.
No, it's not like that. You have a different shop, but in that case, whatever the product that will require the processing, that particular shop will involved in processing of the particular operation. Let's say it's a milling operation on that particular product. But here what we are doing, based on the requirement, we are forming a cell wherein we are bringing the machines which are required to process those particular parts. So we are forming a cells.
So sir, in this case, that suppose we are forming a cell. So in this cell, we have one press, one weld, one paint, and like this. So full
So
one component will be from RM to FG. It will be completed in one cell only, like this, sir.
It depends. If that entire processing from raw material to finished good needs to be done in that particular cell, it can be done in that cell also. Or if it is required few operations will be performed in a cell, and then the product will move out for further finished operation, and maybe based on that, it may be converted into a finished goods also. So maybe you have a layout wherein you have initially some, we can say cells wherein, so this is cell 1, this is cell 2, and the product may come from these two cells, and maybe some processing will be done wherein we cannot form any kind of a similarity between the process. So in that case, then the product may move out as a finished goods. Or it may happen that you have a different cells, and based on the operation through this cell, the product may come out as a finished goods. So it depends on the product. It depends on what kind of processing is required to be performed on that particular product. So depending on the processing operations and depending on the characteristics that we can club to form a part family, you can form the different cells. Okay. So for example, if you can look at this particular situation wherein there are 5 machines, and each 5 machine has a different set of components that need to be that need to process these components. So what we can do in this situation, we can see that how we can club the different components so that those components can be processed by a group of machines. Okay, so the situation may be like this, or you can see here that if there is no grouping, so if you look at the machine component incident matrix, so you can see that there is a wide gap between the different components that need to be processed on the different machines. Okay, but then you can form a part family maybe based on the requirement. So for example, what will be the similarity? It's a requirement in terms of the machine. For example, component 1 and component 1, it requires a machine A. Component 1, it requires a machine D, and machine A process the component 1, component 4. Okay, similarly component 7. So based on these characteristics, how we can group these components so that we can form a cell of machines, and those particular cell of machine can process these particular parts. So the solution, it may result in such kind of the formation of the part families. So you can see that now we have one cell of machine B and C which will process these particular components. We will have a cell of these 3 machines which can process the components 1, 4 and 7. We have these 2 machines as cell. This is, let's say, cell 1. This is cell 2. This is cell 3, which will process these particular set of components. And we can have a cell of machine 4, which can process this particular set of components. So based on the similarity or based on certain characteristics by which we can group these components, and then we can form a set of machines, and based on that, the processing can be carried out.
Sir, can we get a live example of this? Actually, it is a little bit confusing. In this, sir, you are saying that some part of that component will be processed in cell 1, and then in cell 2, and then in cell 3, and then in cell 4.
See, it depends. It depends. Let's say you have 10 components, okay, 10 parts. Out of those 10 parts, let's say 5 components or 5 parts, they need the machining of these 2 particular machines. For example, let's see here B and C. Okay, so whatever those 5 parts, those were, or in this case, there are 4 parts which were requiring the processing to be done on machine B and C only. So depending on this similarity, that these particular group of parts, they require only machine B and C. So what can be done here? We can allocate machines B and C as a part of one cell. All those components will be processed in that, and then they will move further to the next stage of the processing, or next stage of the operation that will be that needs to be done on those particular group of components. So depending on the similarity in terms of some characteristics, we can form the cell or we can form the part family, and based on those particular part families, we can form the cells of the machine, which will be dedicated to that particular part family. For example, here, which is the part family? This is what is the part family. So one part family is now component or parts 2, 3, 5, and 8. So these 2, 3, 5, 8, it will be processed through machine B and C, and depending on if it requires further operation, definitely it will go to the next stage of operation. Okay, or if the finished part, it comes out of these particular cell, it will be so the raw, it will enter as a raw material, and it will leave out as a finished good, maybe from this. So it depends on the type of processing, type of operations that need to be performed, and accordingly it can be formed. So if it is a situation that for the next stage, if we cannot form it as a part family, it's a unique process that needs to be done on all the components which are involved. For example, in this case, there are 19 components. Okay, so maybe based on the processing out of these 4 cells, the products will come out, they will be processed further few of these steps, and finally then it may roll out as a finished good. So it depends on the kind of situation in which we need to perform the processing operations.
Sorry to interrupt, Professor, if I may.
Mhm.
Yeah, actually a basic question was on the components that you are referring to. For example, from component 1 to 19, do they represent the same type of component or a different component?
They are different components.
Different component. Okay, fine. Thank you.
Yeah, they are different components. For example, here, if you look at the component 1, it needs to be processed on machine A, D, and F.
Yeah.
Okay. So it may be a different kind of a processing operation, because each machine, let's say it's a different machine. So component 1, we need the processing on machine A, D, and F. Similarly, component 2, it needs the processing to be done on machine C only.
Correct.
For component 3, you need a machine B and C. So all these different components, they need the processing in terms of the different machine requirement.
Yeah,
so
yeah.
Based on this, now we can form a family. Now, what will be the characteristics in this case? The similarity of characteristics will be in terms of the requirement of the machines.
Correct.
Okay. So which machines are required by the particular group of components, so that those particular components, they can be grouped as a part family, and whatever machines are required to process these components, they can be brought together so that we can form one cell. So this is what is the formation of the cell.
Sir, in this case, like
And it
what I
depends
have,
then how you are arranging those.
sir, what I have understand in this, like for the assembly shop, for assembling a car, we need sheet metal, gears, engines, and that accessories. So you are saying that that sheet metal is one family, gear system and transmission is one family, and engine is one family, and that accessories is one family. We are processing these parts in different cellular form, and at assembly shop we are arranging it like this, sir.
So at a factory level, you may consider, for example, a sheet metal shop. Okay. So it needs the entire processing operation that are related with the sheet metal operation. It may be a stamping and it may be a welding, isn't it? So if it is an example of a car, then you will need some kind of a stamping operations and some kind of the spot welding operation. So all those operations, they are grouped, and we create a kind of a shop. So similarly, in a particular shop itself, depending on the number of products that are processed, if we can identify certain similarity between those components, based on that characteristics, we can form a part family. Okay. And based on those particular part family, we can form a cell.
Understand, sir. Understand.
Okay. So at a factory level, you can say at a broader sense, whatever the different shops, if you are looking at, so these are considered to be the cell which are required or which are dedicated to that particular operation. So within the shop, then there will be certain product. For example, let's say any machine shop. there are number of components that need to be processed through different machines. So here what you can say that this is an example wherein it's a kind of a machine shop which is having the machines A to J, and there are number of components that need to be processed. Now each component will require a different kind of a processing in terms of how is the shape and what are the different, how is the configuration of that particular product. So depending on those particular characteristics, you can form the part family. And within the shop, now for example, if this is the shop, okay. In this particular shop, then we can have different cells. So at a factory level, since it was requiring a machining operation, this is one big cell we can say, isn't it? So let's say if you look at the factory, so this is one, let's say machine shop. Let's say this is one engine shop, and let's say this is one assembly shop. And finally, the product rolls out of here. Okay, so how we have formed these particular departments or section based on the similarity, because we cannot bring the machining operation to the assembly shop. So depending on the requirement of the machining operations only, we have grouped them and we have formed one machine shop. Now within machine shop, there will be certain component, n number of components that needs to be processed. So within those particular products or component, if we find that there exists certain similarity by which we can form them as a part family, we can group them. So within machine shop now, this can become one cell, this can become second cell, this can become third cell, this can become fourth cell. And if depending on this, if the final product it rolls out, it may come like this, or based on the individual processing in the machine shop, let's say there needs a further operation which needs to be performed in this, and maybe after that the final product will come out of that particular machine. Is that clear? So the objective here is how we can identify or how we can form the part families. Based on that, we can form a particular cell. So this particular layout is called a group technology layout, GT cell that we call it. So the formation of the group technology cell. So there are a number of techniques by which we can form the groups. Okay, so we'll look at this example that how we can use the algorithm that is called the rank order clustering algorithm to identify the components which can be formed or which can be grouped as a part family, and based on that how we can configure them as a cell. Okay, so this is what are the steps of this algorithm. We'll quickly look at it. So it uses the binary principle to arrive at the total load on that particular machine, and based on ranking of those particular binary values, it will try to rearrange the machines or the components, and based on that it will try to form the group. So the steps in a mathematical or in the generalized forms are mentioned, or you will find in any literature. We'll see that how we can group these particular set of components which are allocated to a particular set of machines, and based on that how we can form the cells. So this is the same example which we will discuss. So what you have to do, these are the 10 components. So this is the machine. This is called the machine component incident matrix. So these are the number of machines and these are the components. Okay, so what this algorithm says, you have to start with the binary allocation for this particular machine. So you have to start from the right side. No, it's hanged. You have to delete. Okay, so you have to start from this side and then you have to give a binary ranking or binary weight to each of these components. For example, this you have to give as 2 to the power 0. So you have to start with the 0. Then this will be 2 to the power 1.
What is the problem, sir? So if it is better, you can type in OneNote, sir. OneNote.
But I need to do the calculations here.
Okay, sir.
Okay. So 2 to the power 0, then the second will be 2 to the power 1, 2 to the power 2, 2 to the power 3, 2 to the power 4, 2 to the power 5, 2 to the power 6, 2 to the power 7 and 2 to the power 8. So starting from the right side, that means the last job, we have to start giving the binary values for each of these particular column positions. And then we have to find the value of it. For example, 2 to the power 0 will be 1, 2 to the power 1 will be 2, 2 to the power 2 will be 4. So like this, we have to form it and then we have to find the summation of these particular numbers here. Okay, so this is nothing but 512 into 1 plus 256 into 1 plus 128 into 1 plus 64 into 1 plus 32 into 1. So we have to multiply these number with the corresponding row values. That means the number of ones here, and based on that we have to come up with the value here. So based on that, what you have to do is you have to then arrange these in a descending order. So at second stage, what you have to arrange these in a descending order. So if you arrange these in a descending order, so just go to data. You have to sort it. So in the next step, what you have to do, once you have given the binary weight and multiply it with the corresponding values for that particular machine, you have to arrange those in a descending order. Okay, so you can sort it using the sort tab that is available here. So now you can see that it has rearranged the machines. So now based on the rankings of these particular, now this will form rank 1, this is rank 2, this is rank 3, this is rank 4. No, it's hangs.
Are not able to understand, sir, how
Yeah,
this
I'll
binary is calculated, and this is completely
Yes, yes.
disconnected.
Okay, I'll explain.
Can you please repeat? No, it's okay.
So one more thing, that how we have selected from, we are moving from right hand side to left side, because number of activities and importance of the each component is not all the components are important for individual machines, sir. So how we have identified we should move from right hand side to left side?
See, the objective here is that how we can bring these particular numbers which are scattered. Okay, for example, here if you can see that the numbers are scattered. Okay, so what is the objective here? We have to form the combination. Okay, so the algorithm is designed to form the combination. It will not have an effect on the priority that you are mentioning. For example, if component 1, it requires processing to be done on machine M1, it will be processed on machine M1 only. Okay, now in what sequence it will be processed, that's a part of scheduling. Here, what is the objective? Is that how we can group those components. So to create a grouping, we are using the particular algorithm which is based on creating a ranking based on the binary weight characteristics and utilizing that to bring those particular parts or components together so that we can form a cell. So whatever you said that it will have effect on the we can say the character of the priority or the characteristic, it's not going to affect any kind of a priority or whatever you are thinking, maybe based on grouping of these particular components or parts. So
Okay,
here
sir, it will not
the
have any
objective
impact
is,
on.
see here the objective is only to group the component, and for that the algorithm is using the binary weight characteristics. Okay.
Sir,
Huh.
if if product 1 has to run first on machine 1 and 3 and then 5, but in the machine but in part 2 the sequence of the machine change, in this condition what we have to do?
It's not going to affect. See, sequence is a different characteristic, different operation, or the sequencing will be a separate part of the operations planning. Here it's a part of the layout planning wherein you are looking at which product will be grouped to form the cell. Okay, in what sequence that will be processed, that will be a separate part of the operations planning. wherein you
Okay,
will
sir.
have to use the sequencing and scheduling algorithm, and then you will decide that which product will move first, which product will process second, so on and so forth. So it's not going to have, or it's not going to have any effect or any concern with the scheduling. And that is what is the part of any layout planning. Here you are just looking at the layout planning, not the scheduling or sequencing. So you can see that whatever components, they are scattered at a larger level. So if you can see that here, when you have 19, 20 components, you can see that they are so much of scattered, requiring a different machine. So what you are looking at, how you can bring those together so that a particular group of machines can be formed as a cell, and maybe those particular component will be allocated to that particular cell. So it will simplify your operations planning and the layout arrangement also.
Sir, if I try to understand, basically I am working in body shop.
Mhm.
To make one body shop of a car, we make a different lines, like one line for the door, only to make doors of the line, one line to make a complete floor of the line, where the specific number of machines or fixtures will be used only to make floor. So we lay out in a particular location, which called a floor line. Same way we make a line for the doors, where the robot will only make the doors only. So we call it door line. So all the door parts will be means kept there with the machines which has to be used. So that way this layout will work out, which you are telling, which I am understanding. Am I right or wrong?
So maybe in that, whatever the doors that you are manufacturing, depending on the number of operations that are required to be performed, okay, you have formed those, you have grouped those, and accordingly you have arranged your whatever the manufacturing facilities that are required, and you have formed that particular department or section.
Yes.
Similarly, in any industry, if let's say if it's a machine shop, wherein the machine shop needs to process n number of jobs, let's say 20 jobs. So in those 20 jobs, if we can find certain similarity. Now here, what is the similarity here? The similarity is in terms of the processing steps that are on that particular part. For example, it requires machine M1 and M2 only. And let's say M1 and M2 is a lathe machine and a drilling machine. So whatever operations that are performed on those particular parts, they are needing only the lathe and the drilling machine or the milling machine. So based on this similarity, we are forming them as one part family. And then we are allocating those to the particular group of machines that will be formed or that will be called as a cell.
Yes, sir.
Sir, hello. Sir, a small question. This layout planning is done before startup of the plant, as I concern, because in the running plant, when the assembly line is running, so this grouping is already done. So this is the planning part before start up the plant, as I concern. When I am going to start a new plant, that is the one task. Okay, how we will group the machines, how we will make the cells. So this is the part of before start up the plant. I think in the running plant, in the running manufacturing facility, this planning is not so much beneficial, because already this is done before starting the plant, as per my concern. So this is the project stage planning. This is the project stage planning.
Yes. So depending on your process planning, you can identify these kind of requirements, and when you are planning for the layout, then at the planning stage itself, you can think of either creating a group technology layout, or creating the process layout, or creating the product layout. So that is what it happens in many industries. That why do we have, for example, in a car manufacturing plant, the final assembly shop is a kind of product layout. So depending on the requirement of the assembly, we are making the layout as a product layout. But maybe in some kind of a machine shop, we may have a process layout, or if you find that based on the process planning of that particular, the entire products which are machined through that particular machine shop, if you find a kind of similarity, then you may have a combination of a group technology layout, and it may be further a process layout. So it depends on the kind of processing that is required to be done on the particular set of products. And based on that, what kind of layout that you can plan for carrying out the required production.
Correct. Okay.
Okay.
Fine.
But then in many situations, you will find that based on the productivity output or based on the efforts of the company, maybe as a part of continuous improvement, they can reconfigure the machine, and based on that, you can go for a product layout, the group technology layout as well. So maybe initially you have formed the layout as a process layout, but at a future stage, if you get a new orders wherein you require that whatever products that you are processing, if you find some kind of a similarity between the processing operations, if you change your layout to a group technology layout, that will give you a better productivity as compared if you are already having a process layout, and if you are looking at utilizing the same process layout for those products which have certain kind of a similarity which can be grouped together. So definitely it will result in less productivity if you are not utilizing the benefits of the group technology. In that case, it will affect your resource, it will affect your material planning. So there may be so many cost heads or so many parameters that will involve that may have an effect on the productivity also.
Yes.
Isn't it?
This,
So it
this may
depends
be
on the
this may
requirement
be
and the
applicable for
situation.
any expansion of the plant. If we are going for any expansion of the
Correct.
existing plant,
That's
so
what I'm
we
saying.
can
That if you
consider
are
this
looking,
group planning. Say what we can modify in this planning for the current scenario or the current order which we have.
Correct. Yeah. So if you are looking for the plant expansion, so in that case, if you are expanding the plant maybe for the new orders wherein you find that some kind of a processing similarity exists for which there can be a formation of a part family, you can utilize the group technology layout. Okay, so we have to start from the right side, and then we have to give a binary weight to each of these particular component: 2 to the power 1, 2 to the power 2, 2 to the power 3, 2 to the power 4, 5, 6, 7, 8, 9. And based on that, you have to estimate the values of it. So for example, this is 1, this will be 2, this will be 4, 8, 16, 2 to the power 5, 32, 64, 128, 256, and 510. Okay. So this algorithm is basically to form the group so that we can bring all those components which are having the similarity of the requirement. And then you have to find the product of it. For example, 512 into 1 plus 256 into 1 plus 128 into 1 plus 64 into 1 plus 32 into 1. Here it's 0. Then 8 into 1 plus 4 into 1 plus 2 into 1 plus 1 into 1. And you have to do the summation here. Similarly, then for this particular row, then for this row. So at each stage, you have to multiply the corresponding cell values and come up with the total. And out of these, then you have to create a rank. So you have to rank them in terms of higher to lower values. And then you have to arrange those in the particular ranking. That's why the algorithm name is called the rank order clustering. So based on the binary weight, you are trying to create the ranking, and based on the ranking, you are trying to club those particular components so that they can be formed as a group. So this is an iterative process. So these iterations need to be performed, and based on the iterations, then it will come up with the particular combination. So that's why you can do it well with the Excel, wherein you can form it. So whatever summation that we discussed, the summation is done here. And based on that, now you can see we have created the ranking. For example, this is 1, this will be 2, this will be 3, this will be 4, and this will be 5. And you have to then arrange those in the particular ranking. And based on that arrangement, you have to reconfigure the machines. So for example, here, based on the ranking, you can see that now the machines are configured as or reconfigured as M5, M1, M3, M4, and M2. In the second stage, then whatever this particular grouping is formed, you have to do the row operation. So again, here you have to start with the binary weight from bottom to top. Okay. So here it will be 0, here it will 1. So this will be 2 to the power 0, 2 to the power 1, 2 to the power 2, 2 to the power 3, and 2 to the power 4. And again, what you have to do, you have to multiply it with the corresponding column values. For example, 16 into 1, then 8 into 1, then 4 into 1. So 16 plus 8 plus 4, that will be 28. So this will be the column summation. So similarly, for each, you have to form the column summations here. So this is nothing but what? So this is nothing but 16 into 1.
So touch this.
Huh.
So, as of now, can you write in PowerPoint, sir? I will change this one break.
Okay. Okay. Okay, so you have to multiply these binary values or binary equivalent with the corresponding column positions, and then you have to add it. So for example, here it will be 16 into 1 plus 8 into 1 plus 4 into 1. So that will get to a 28. For this particular, it will be 16 into 1 plus 8 into 1 and plus 2 into 1. So wherever there are no values, it's a 0 here. So you have to do it, and you can do it using the sum product function. So in our previous session, we discussed about the sum product function. So it's a sum product of these values with these values. So this sum product you have to do, and then again you have to rank it. So you will have to rank these values. So for that, what you can do, you can now you have to rank those. For that, you will have to select with the components and then go to the data, sort. So here now you will have to sort it in terms of the row values. So you will change it from the options. So from left to right, click OK. So you will sort it based on which row? This is row number 24. From largest to smallest, because we are ranking those. So if you rank those, so you can see that now this particular grouping has formed. So you have to repeat it first for the column operation and then with the row operation till any further change. So in the second stage, then again I have done the grouping here based on the row values and column values. So again you have to repeat the process. You have to give ranking. First the binary weight, calculate the values based on the sum product function by multiplying with these particular values, and then you have to rank those. That means you will arrange those in a descending order. So based on it, what you can see, you have to do the row operation and column operation. This process needs to be repeated till the rearrangement of the components and the machines, they does not result in improvement in the solution. That means there is no further change. So at this particular time, then you can see that we can form the groups here. Like this particular group of machines will be performing this. So now we have formed one part family here, which will involve component 1, 5, 7, 2, 3, 4, 8, and those will be processed by machine 5 and 1. Similarly, these particular components 1, they will be processed by 3, and these particular component, they will be processed in this. So now we can see that these particular cells and definitely these products 6 and 1 will be included and they will be processed as per their processing requirement. But initially, if you can see that whatever the components were existing, which were existing in a very haphazard manner, they are now being grouped. And based on that, we have come up with a layout wherein we have one particular cell of machines, one particular group of machines, that is cell 1, where machine 5 and 1 will be located. In machine, in another cell, we can have a machine 3, and then in another cell, we can have machine 4 and 2. So in this way, you can group those components and you can form the cells, which will become a part of the group technology layout, or this cell, this type of layout, we call it as a group technology cell.
Sir, but still machine 3 is required for other purpose, no?
Yes, yes. So those components will be processed on those particular machines. We are not going to skip those. But then to form the layout, that in what way you will keep the machines. Okay, this will help you that machine 1 and 2, if you group machine 5 and 1, if you group them together, so that you can identify the group of parts that will be allocated to the particular cell. So it will help you in your material planning. It will help you in your other resources planning as well. Okay, for example, if with this initial arrangement, if you can see, it will result in a difficulty in terms of your other resource planning. But if you allocate in this particular type of cell, so it may happen that since the machines are now grouped, you may have, and if it is a kind of a CNC machine, you may have one particular operator who will be working on this particular machine. So in that case, in the haphazard manner, you may require 2 machine operator, but in this case, you may require only machine operator. So in terms of the resource requirement and material planning, this grouping will help and it will give you a better productivity as compared to the other layout.
Sir, what's the reason the other allocations are not highlighted green? Why the other allocations are not highlighted as green color? What's the reason?
See, it's a kind of the algorithm, or it's a kind of an optimization problem. Okay, so maybe this algorithm is coming up. This is not the only solution. Okay, this algorithm is coming up with this solution. There may be certain other algorithms or other technique which may come up with the solution in which you may not have such kind of machines which may be remaining. So this type of problems, they are a combination creation kind of a problem. And there will be n number of combinations that can be possible. So this is just one of the combinations.
Sir, how the conclusions are derived, sir? I didn't understand. Because the machine 2 and machine 4, there are products 4, 5, and 6 which can be grouped together, no, sir? So they're also together.
Which
how
one?
The machine 2 and machine 4, there are products 4, 5, and 6, which is why those are not grouped together. How did we conclude that machine 1 and 5 should be grouped together for a product 3 to 9? That's how the conclusion is derived. I didn't get that.
No, if you find those, you can group them together also. So the idea here is that whatever the parts that you will be processing, if you are able to club it and form a cell, okay, so that way you can club it. Okay, so this is just one solution that I have presented it, or this algorithm has come up. We have not solved this algorithm till the end. I have just explained you the approach. Because it will take a lot of time if we completely solve it. So I have explained you the steps. So maybe based on that, you can try it on your own, and maybe based on that, you can see that it may come up with a different combination.
Sir, how do we know that out of different combination, which is the optimum solution?
See, each algorithm, it terminates at certain point, which results in the output, which we have to accept it as an optimal solution. Okay. So different algorithms will have a different accuracy in terms of giving you the optimum solution. Because such kind of problems which are having a solution in terms of the combination, whatever the algorithm solution it will give, it is one of the solution may be based on or out of n number of solutions that may exist for the particular problem. And that we have to accept it for implementation, because we don't have any other option by which we can get the final or the ultimate best solution. Okay, so this was about the rank order clustering algorithm by which we can form the groups. Okay, so as a part of the systematic layout planning, we looked at forming the layout, and based on the initial layout that is created, we can improve that layout maybe based on the pairwise exchange in the particular layout. So there are different techniques that are available. Craft is one such technique that is called the computerized relative allocation of facilities technique. So this is basically a layout improvement technique. So whatever initial layout that you have, you may improve that layout based on the pairwise exchange. Okay. So for example, this is the layout wherein we have department 1, department 2, department 5, department 4, and department 3. So based on maybe any other approach, for example, like the systematic layout planning that you have utilized, and you have come up with the initial layout. And now based on the pairwise exchange, you can look at that if you do the pairwise exchange, and if you come up with a better layout in terms of the movement of the material, which may result in some kind of a saving, you may improve that particular layout. So in our previous session, we discussed about the different from to metrics. Okay, so let's say the three elements which are related with this particular layout, that is related, let's say, with the material movement. So we have a flow matrix here. So the flow matrix, it represents how many trips of the material flow will occur between the different pair of the department. For example, here it's a flow of 5 trips between department 1 and 2. Similarly, from department 1 to 3, there is a movement of 2 trips. Maybe from department 1 to department 4, it's the 4-trip movement, so on and so forth. So in case of any layout, there will be a flow of material that will take place from one department to another department. Similarly, each flow will result in certain cost. Okay, for simplicity here, I have considered the cost as 1 only. But in real life situation, whatever cost that is involved may be based on the movement of the material handling devices. If you are able to come up with the cost, so you may utilize those cost values, and based on that, you may come up with the values, and you can utilize in these particular cells. So we have a cost matrix, we have a flow matrix, and then we also need to have a distance matrix. Okay, and based on this, we can calculate the total cost. So the total cost will be the summation, it will be cost multiplied by flow multiplied by the distance. Okay. Now,
So I will change the laptop once. Okay. The breaks are, I think it's brand new, but break I will change.
Okay, so for calculating the distance, we need the coordinates. So let's say plant 1 is having an area of 16. So let's say these are the dimensions of the plant 1. So plant 1, department 1 is having a dimension of 4 by 4. Similarly, department 2 is having a dimensions of 4 by 4. Department 5 is having a dimension of 4 by 2. Department 4 is having a dimension of 4 by 4. And department 3 is having a dimension of 4 by 6. So based on this, we can find the coordinates. For example, the coordinates of department 1. So these are the centroidal coordinates. So whatever the center of this particular department, the coordinates we have to find. For example, department 1, what will be its coordinate?
2, 2.
So let's say here we have an axis. So the axis is represented like here, X and Y. And here is the origin. So what will be the coordinates of this? This distance is 4. And the centroidal distance, this will be how much? It will be 2 and this is 4.
2, 6, sir.
Similarly, what will be this distance? It will be 2. Because this is a centroidal distance. So what will be the coordinates of department 1? This will be 2 and 6. Similarly, what will be the coordinates of this department 2? Here is the centroid, let's say. So this distance is how much?
2,2.
This is 2. And this distance is again 2. So the coordinates of department 2 is 2 by 2. So in this way, we have to find the coordinates for each department, and based on the rectilinear distance, because so when I'm switching between these two, it's creating a hang.
Yes, sir. I think when
Okay,
you're
now
writing in
I will use this only. then.
Okay.
Okay. Let me switch between these slides now.
Yes, sir.
But you look into this problem.
Yes, sir. I will change the laptop. Of course. I'll change the laptop.
Okay.
Only when we write use the pen in the Excel. That's when
That's what it's creating a problem.
Creating problem.
Okay, so we will use here the rectilinear distance. Okay, so the rectilinear distance is nothing but, so let's say if there are 3 points, 1, 2, and 3. Okay, so the distance or the movement in terms of the right angle, that type of movement is called the rectilinear movement. And if you are moving from point 1 to 3, even along the diagonal, that is called the Euclidean distance. Okay, so this is rectilinear distance wherein we are moving or we are measuring the distance along the right angles only. So you can find that in any particular plant, the movement or the aisle movement is always along the rectilinear path, because there will be always only a right angle turns will be allowed. So that type of distance or the movement will be a rectilinear movement. So in this case, since this is the movement is related with the movement inside the plant, we will consider the rectilinear distance. So now from plant 1 to 2, what will be the distance? It will be so the distance between 1 and 2, it will be mod of x1 minus x2 plus y1 minus y2. So if you measure it, so what will be x1 minus x2?
0.
2 minus 2, this is 0, plus y1 minus y2 will be 6 minus 2. And you have to take a mod value. That means you have to only consider the positive value. So the distance between 1 and 2
4
will be how much? 4. So pen is creating a problem actually. So distance between 1 and 2 is now 4. Similarly, can you find the distance between 1 and 3? So it will be x1 minus x3 plus y1 minus y3. So x1 minus x3 will be how much? 2 minus 7, that is minus 5. But then you will have to take it, the mod of it, that is plus. So this is 5. And what will be the distance between 1 and 3? It will be 6 minus 2, that is 4. So 5 plus 4, it will be 9. Similarly, can you find the distance between 1 and 4? So this is 1 and 4. So it will be x1 minus x4 plus y1 minus y4. So x1 minus x4, it will be 2 minus 8, that is minus 6, but we are taking the modulus, so it will be plus 6. And y1 minus y4, 6 minus 6 will be 0. So this will be 6. So the distance between 1 and 6 is 1 and 4 is 6. So in this way, based on the coordinates, you have to find the distance, and then the total cost will be the product of cost multiplied by distance multiplied by the flow. So for example, the total cost of 1, 2, it will be 1 multiplied by 5 multiplied by 4. So it will be 1 into 5 into 4, that is 20. Okay. Similarly, for what will be the value total cost of 1, 3, it will be 1 into 2 into 9. So 1 into 2 into 9, that will get to 18. So in this way, you have to form the total cost for each pair of the departments. And for this particular layout, the total cost, if you sum all these values, it gets to 205. Now, this is what is the initial layout. And now, if we do the, or if you improve the layout by doing the pairwise exchange, that means if we are exchanging the department. So the exchange is possible where there is a common border. So for exchange, you have to consider common border or the same area. Okay. So for example, in this case, based on these two characteristics, 1 and 2, can they be exchanged? Yes, because they have a common border as well as common area. Similarly, 1 and 5, can they be exchanged?
Yes.
Yes, because they have a common border. Similarly, 1 and 4, they don't have a common border, but then they have a common area or same area. 1 is also 16, 4 is also 16. So we can exchange this department. Okay. Similarly, 1 and 3, can they be exchanged?
No.
They cannot be exchanged because they don't have a common border and their areas are also different. So based on these two, you have to look at which departments can be exchanged. Okay. So as a part of this algorithm, we have to evaluate the total cost for each of the exchange. And then based on which exchange it results in a lower total cost, you may create the particular exchange, and in that way, you may improve the layout. Okay. So this algorithm is again a repetitive kind of or iterative kind of algorithm wherein based on the pairwise exchange, you have to estimate the total cost, and based on the total cost, whichever layout is giving you the lowest cost based on the exchanges, that layout you will select. Okay. And that particular layout will become a new layout. Again, you will apply these steps of the algorithm wherein you will look at the pairwise exchange between the departments, and this process will be iterative, it will be repetitive till you get some kind of an optimal solution. Okay. So we will look at one such exchange which may be possible. So can you work on the interchange between department 1 and 4? So the cost matrix and flow matrix will remain same. Only the change will occur between the distance metric. Okay. So if this is the layout, and if we are exchanging 1, 4, okay, so what will be the coordinates of the department? X1, Y1?
Eight and 6.
Okay, so now what we are looking at, we are exchanging the departments 1 and 4. So 1 will come at the place of 4 and 4 will come to the place of 1. And now the coordinates will change. So what will be coordinates of 1 now? So 1 is now here.
8.
And 4 is here. So the coordinates of 1 will become
8.
X will become 8.
6.
4 plus 2, 6 plus 2. Because this is now department 1 and this is the centroid. And what about Y coordinate?
6.
It will be 6. For 2, it remains same. Because 2 is remaining at the same place. So it will be
2,
2, 4. No, 2, 2.
2.
For 3, it remains same. So how much it will be?
7.
7, 2. For 4 now, 4 has come here. We have exchanged the department.
2,
So it becomes 2, 2. And for 5, it remains the same. That is
6.
5 and 6. Okay. So based on this now exchange, what you will calculate? You will first find the coordinates, and based on that, you have to find the distance. So now what will be the distance between 1 and 2? Based on these coordinates, it will be x1 minus x2 plus y1 minus y2. So 8 minus 2 will be 6, plus 6 minus 2 will be
10.
4. So the distance will now here. For the 1 and 4, the distance here will be 10. Similarly, between 1 and 3, it will be 8 minus 7, that is 1, and 6 minus 2, that will be 4. So
5.
It will be 5. So in this way, you will have to find the distance between each pair of the department movement, and based on that, you will then estimate the total cost here. And let's say for here, it gets to 193. So you can see that for the earlier arrangement of layout, the total cost was 205. And with this exchange in the department, your total cost has reduced. Okay. So you will have to perform these kind of exchange between all the department based on either the common border criteria or maybe based on the same area criteria. And you will have to evaluate all such exchanges, and whichever exchange or the combination of the layout will give you the lowest value, that will become the new layout. Okay. And again, for that new layout, you will consider which exchange is possible. So in this way, based on the creation of the initial layout, using the craft procedure, you can improve the layout. So this is how you can improve the layout based on the craft principle. So you may try for few more exchanges, and based on see that how you can compare the exchanges, and based on that which department will result or which combination of the exchange will result in the total cost, that you can consider it as the improved layout as far as that layout arrangement is concerned. But again, it's a kind of a combinatorial problem. So you may have a different combinations of the solution, and whatever approach that you will be using, that may give you some kind of a solution which we can consider as a near optimal solution for the problem. Yes, Mr. Purushottam.
Sir, I have a query. You explained that for interchange, there are two
Mhm.
criteria to be met. One is common border and same area. So when it comes to 1 and 4, same area is there, but common border is not there. 5 is in between,
So you
right?
can exchange the department. Na? For example, this area is 1/16. Area of 1 is again 16. So you can exchange the operations of the maybe the facilities of layout of the department 4 and department 1. But then based on the material movement or whatever the criteria of the flow, okay, you may evaluate that department in terms of the total cost that is involved.
Okay, sir. My query is whether it is either or for common border and same area, or both should be satisfied while interchange.
No, either or.
Okay, okay, sir. Fine, clear.
So you may exchange 1 and 5 also. So same way I have done it for 1 and 4, you will try. So as a part of the craft procedure, you have to look at the possible interchanges between the department. For each interchange, you have to find the total cost, and whichever layout will give you the lowest cost, or whichever interchange will give you the lowest cost, that will become the new layout. Okay. And again, for the new layout, you have to again try with the exchanges. And in this way, this process is an iterative process.
Yes, sir, is it possible to replace 3 and 4 because the length and width are different for both?
So that's why it's not fulfilling the criteria. 3 and 4 cannot be moved.
Or combined 4 plus 5 and 3 can be replaced in that way. It can be moved up and 4 and 5 can be moved down.
So these two you are bringing it down, and these two you can try that because that's also a new layout. As a part of the algorithmic approach, whenever you will implement it, maybe with some computer program, you will need certain criteria. So this is what is the criteria which is utilized for the interchanges, coming up with the new layout, doing the estimation, and comparing the performance of the different layout configurations so that you can come up with the improved layout as far as the arrangement is concerned. Is it clear? Okay, so we'll stop here. We'll take a break of 10 minutes and then we'll continue again with the session. Okay, yeah, thank you. Okay, so we discussed about the craft, that is the layout improvement technique. So and we also discussed about how we can form the cells based on the requirement in terms of forming the group technology cell. So now we'll discuss about the facility locations problem. Okay, because we can see that whenever we are looking at a new facility that needs to be located, maybe it's a part of a new organization that we are setting up, or it may be some kind of an expansion. So there may be multiple situations in which we come across this kind of a decision where we are looking at the decision on locating a new facility or maybe any other facility. So there are many situations in which we look at the facility locations problem. If you have gone through the textbook, maybe a chapter on this, so you may be aware with this Akshay Patra Foundation, this organization, they provide the midday meals to the different schools. So you can see that there is a requirement in terms of locating the centralized kitchen, because there is some kind of distribution and logistic costs associated with the supply of the meals to all these schools are concerned. So in that particular situation, looking at the quantum of the kind of activities that are involved in the organization like the Akshay Patra Foundation. So if we look at their working and their organization, the problem for this type of organization will be arise in terms of where they should locate their centralized kitchen. One solution may be that they can have a kind of a smaller kitchen, maybe at each of the school location, but then that will increase the cost of the operations. And if they are looking at creating the centralized kitchen wherein they will cook the food in a larger quantity and maybe based on the utilization of different vans, they will circulate it to the entire schools for which they want to provide the meals, then it will result in a cost of distribution and the other logistic costs that will get involved. So in such situation, the problem here it arises, or the problem here is to look at that where they should locate their facility. So as far as their operations are concerned, they have a number of centers in different states, and in each state they have a number of cities from which they operate. So this is one of the location or the facility which is located in the city of Bangalore. So in Bangalore, they have two centers, and this Vasantpura is one of the kitchen, centralized kitchen that they have utilized for cooking the food, and maybe based on that, they will supply it to the different schools which are nearby. So from this particular facility, which is at Vasantpura in Bangalore, they deliver food to almost 530 schools. Now to cater to 530 schools, the location or the facility where they will keep their kitchen, so that will result in their distribution and the logistic cost to a certain minimum value. So that is one of the classical decisions that they need to take into account when they are looking for this problem where they should locate the facility. So you can see that the decision is involving so many criteria in terms of preparing the food and then distributing it to this nearby school, because their operation will start at almost starts at 4 a.m. so that they have to cook the food, and then that food has to reach to the school before the break occurs at the particular school for the lunch. So that means if the break it occurs at 1 o'clock, then they have to reach the food to all the schools by at least 12:30, so that the food will be available to all the students or the kids who are studying in those particular schools. So in such type of situation, you can see that the problem of the facility location is very important. So in other situations also, if you can see that the facility location is a very critical decision, and if we look at the facility location decision is a strategic decision, because once you have located the facility, you will see that there will be number of resources which will be involved in that particular decision, and if that decision turns out to be wrong, in that case it becomes a very critical issue or critical decision if you have to locate that particular facility, or if you have to change the particular location of that particular entity. It may be a manufacturing facility, it may be a warehouse, or it may be even any service facility. So facility location is a very critical decision or very critical aspect as far as locating the facility is concerned. So you might be aware with what happened with the Tata Nano project when it was earlier planned to be located in the Singur at West Bengal. So because of there were certain issues, the plant has to be located to a new location. So you can understand the criticality that might have been involved in such situation. So from that point of view, facility location is a very important decision. And then whenever you are looking at a facility location problem, you have to look at number of aspects. Okay. So facility location is basically a strategic decision. That means it's a top level decision wherein whatever the top management they are involved, they have to arrive at the decision on where they should locate the facility. Because once the facility is located, it's sure that at least for next longer period of the duration, that facility has to remain at that particular location. And there are other aspects, or there are so many aspects which are concerned with the whole environment in which the particular firm it operates and it involves the entire resources. Because you can see that when the decision to shift the plant from Singur to the other location was involved, what kind of resources handling and resources planning that could have been involved in that particular decision. And whenever you are looking at any facility location decision or facility location problem, it has a long-term effect on the company's operations are concerned, because any facility decision or any facility location decision will have a very long-term effect. Okay, because it's not a kind of a decision wherein you will look at locating the facility, you will use it for next 1 or 2 years, and then you can change it to some other location. So from that point of view, facility location is a very critical decision, and it's part of always a strategic decision is concerned. Now, what are the situations in which you need to look at locating the facility? So it may be a situation where you are starting a new factory. So in that particular situation, you have to take up a call and decision based on the operational requirements are concerned, or based on the other requirements are concerned, that where you will locate your factory, in which state, and in particular state, which part of that particular state you will select, so that you will have a kind of smoothness in your operational requirements are concerned. Or in case of an existing factory where you are looking at expanding the factory, so you are looking for the plant expansion, wherein you are looking at expanding the existing capacity and facilities. So in that case, you will come across a decision that whatever the expansion that you are looking for, where you will do it, what kind of location you will select for that. Similarly, whether to look for the new location for the additional facilities, or in a situation where you find that it resulting in a very lost situation and you are looking at closing down the existing facility to take the advantage of some new location. So in all such decisions, you will come across the facility location problem, and you will need to take into account the different aspects which you have to take into account as far as any facility location decision is concerned. So there are a number of factors that you have to take into account. Maybe it's the availability of the raw material, maybe it's the availability of the other resources, maybe the skilled manpower is concerned, or the government, the regulatory policies. So there will be n number of factors that you have to take into account. For example, if it is a kind of a decision for an organization like Infosys or a TCS, where they are looking at locating their maybe the BPO operations, or if it is a kind of a software development operations they want to start. So definitely what factors that are influenced, or what factors they govern the requirement in terms of these particular industries are concerned, they will have to select the particular location. Similarly, if it is a textile industry, the factors that are related with the textile industry in terms of the availability of the proper climate is concerned. If it is a steel industry, if it is an automobile industry. So depending on what kind of facility that you are looking at for locating, you have to look at number of factors. So nowadays, when you look at that with the globalization, there are many industries, multinational companies, they have to set up their operations, they have to set up their plants in the other parts of the world. So whenever any multinational company as a part of globalization, if they are looking at locating their facilities, they will have to look at number of factors. For example, the regulatory norms or the regulatory policies in that particular country. What are the economic reforms that have been initiated by the government in that country? Then what kind of factor in terms of the cost advantage they can enjoy or they can get, maybe based on the quality and the cost of the labor that will get involved. For example, if you can see that almost 15 years back, there was a boom in the BPO industry. Okay, so as far as the countries like India is concerned, we are having a lot of English speaking community, we can interact in English. So that became an advantage for the countries like India, and that's why you can see that many foreign companies, they have transferred their BPO operations to the developing countries like India. Similarly, in other countries like China and even in India, we can find that as far as the labor cost is concerned, it is cheaper as compared to the labor cost which is involved in the US or the European countries. So from that point of view, these countries, they can have an advantage in terms of the cost if they shift their operations, if they shift their maybe the manufacturing to these countries, the developing countries, where they can have the advantage in terms of the cheap labor. So similarly, all these developing countries, they are now looking at the expansion purpose in terms of the development activities they are concerned. So because of the globalization, we can see that there is an expanding market that is available for many multinational companies in these developed countries. So in all such decision, where they should locate the particular facility. So facility location decision or facility location problem will form a major part of their decision as far as these locations are concerned. So whenever any organization is looking at the location problem, or they are looking at the choice of the location, they have to look at the number of factors like the economic reforms are concerned, then what kind of new emerging economies that are coming up. So based on these, there can be a choice for all these multinational companies that they have a multi-global, multi-location or the globalized operations they are concerned. And you will see that many multinational companies nowadays, they are setting up their operations in many developed countries, many developing countries like India or China or other parts of the world are concerned. So whenever we are looking at the competitiveness of any location is concerned, so there exists a three-tier kind of a model. So at the outer level, whenever any multinational company, if they are looking up at setting up their operations in any other country, the first level or the first tier that we can say is the country competitiveness in terms of what are the government regulations, what are the government policies, then what kind of quality, what kind of judicial and the political the organizations that exist, so that they will not have any problem as far as their operations are concerned. Then how are the government policies or the regulatory policies as far as their openness to international trade and the finance is concerned, or the other aspects that the government will try to promote for these companies who are looking for setting up of their operations in the other parts of the country. So you can see that nowadays in India, the government has given promotion to the foreign direct investment is concerned. We have a single tax kind of a system. So all these factors, they will be very important as far as any multinational company that is looking up at setting up their operations in the countries like India is concerned. Then at the second level, there will involve a kind of sectorial competitiveness in terms of what kind of labor that is available, what kind of market flexibility that is available, then the quality of the infrastructure in terms of the electricity is available, then the other factors which are involved in terms of the logistic, in terms of the transportation. So whatever the other infrastructural aspects that are concerned, then what kind of technology that exists in that particular state. So if you look at the different, we can say the competitiveness of the different states are concerned, you will find that there exists a lot of diversity even in the different states of our country also. So from that point of view, whenever any multinational company, they will look at setting up of their operations and they are looking up at the facility location decision, they will have to look at all these three levels, and accordingly they will have to get into a decision of locating the factory. So at the sectorial level, whatever the infrastructural facilities that are available at that particular location, and maybe at the company level, what kind of competitiveness it exists in terms of the available facilities for the design is concerned, the marketing is concerned, then the other aspect of the business and the management of the entire business are concerned. So whenever any multinational company, they will look at setting up of their operations, and when they will look at setting up of their facility, they will have to look at these three tiers. So maybe at first the country competitiveness, maybe at the second the sectorial competitiveness is concerned, and maybe at the third what kind of local facilities that are available, so that will result in an effective operation of their business is concerned. Okay, so we can see that whenever we are looking up at any operational, any location decision is concerned, there are certain factors that we need to account, we need to take into account. It may be a market related factor, it may be a cost related factor, or it may be the regulatory and policy issues are concerned. So if you look at the market related factor, market for products and services. So what kind of market it exists for that particular product and service? For example, if it's a kind of software products are concerned, if it is a kind of an automobile products are concerned, and then if it is a kind of the textile products are concerned. So depending on the market that exists in that particular location, similarly, to what extent the raw material is available. So if it is an automobile industry, so what kind of vendors that are available? So for example, if any car manufacturing industry, if they are looking up of setting up their plant in a particular location, so definitely they will have to look at the availability of the raw material, the availability of the different vendors who will be able to supply the different components to the particular requirement of that particular, maybe the automobile is concerned, whether it's a truck or whether it's a car. So similarly, the number of and proximity of the suppliers will be available, then availability of the skilled labor or the manpower. So if it is a kind of an automobile industry, if it is a kind of a software industry, if it is a kind of a steel industry, so if it is a forging industry, whatever. So depending on the type of industry is concerned, the factor that you will have to look at in terms of the availability of the skilled labor, and of course the quality of the infrastructure, even the quality as well as the cost also, because you can see that there exists a different kinds of tariff rate as far as the electricity is concerned in different states. So whenever any industry, they will look at setting up of their operations or locating their facility, they will have to look at all these factors. So similarly, there will be the issues related with the cost. It may be the wage rates, because we can see that whatever the quality of labor that is available in the different parts of the country, the labor rates are also different. Okay, so if you go to the extreme north, the rates that may be applicable or the wage rates may be applicable in Punjab, or if you go to the south, maybe to Kerala, you will find that the labor cost is higher. So whenever we are looking at setting up of the particular facility or locating the facility, we have to look at all these factors in terms of the wage rate, in terms of the transportation cost, and in terms of the taxes and other tariffs that are involved in that particular the organization is concerned, whether it's a manufacturing organization or whether it's a service organization is concerned. Apart from that, as we have already discussed, whatever the regulatory norms or whatever the regulatory policies, to what extent the government is promoting that particular industry, to what extent the government is promoting that particular business, that also needs to be taken into account. And apart from these technical aspects, there is a requirement in terms of the other issues. It may be in terms of the culture, it may be in terms of the climate, it may be in terms of the social culture that is involved in that particular state, or even the quality of life that is involved in that particular city or that particular state. So you'll find that as far as the software industries are concerned, you will find that most of the software industries, they are either located maybe in the Bangalore initially, or Mumbai or Pune region, because the factors that were that were relevant or suitable for these particular industry, they were mostly existing in these parts of the country. So the initial development of these industries, they started in these particular regions, but over a period of time now, since these regions are getting saturated, the industries, they are now getting into the tier 2 cities, or to some extent to tier 3 cities also, to take into advantage of the factors which are related to the operations of these particular industries are concerned. So whenever we are looking at any location decision, we have to look at the relevant factors which are responsible for the operations of that particular industry is concerned.
Sir, what are these trading blocks? Trading blocks in
Which
the
one?
Trading blocks and regulatory and policy issue mein. Third one is the trading blocks.
To what kind of maybe
Regulatory
based on
policy
what
issue.
kind of trade policies that the particular the location that it promotes. Okay, so depending on the different states, there will be different kind of the trade policies that the government may have. So it's a part of the regulatory aspects which are concerned with that particular location is concerned. So it depends on what kind of trade promotions that even the government supports. So all these factors will be related to that particular location is concerned. So in many areas or location, you can find that the special economic zones are being created. Okay, then the technology parks have been created. So this is a part of the promotion or the trade promotion which the government is supports, and maybe based on that it will attract the particular industries in that particular location. So similarly, you will find that nowadays in many parts of the states, they have created the logistic parks where they are promoting the logistic industries to come up and set up their facilities. So that kind of trade promotions or the trade policies, that particular location, to what extent it is providing, so that will also become a part of the government or the regulatory policy issues as far as the location decision is concerned. Is it clear? Okay. So there are many methods, or there are different models which we can utilize for the location planning decision is concerned. The kind of situation we may come across is one facility and a multiple candidate situation wherein there are multiple candidates that needs to be served. For example, let's say we have a number of warehouses, okay, and there will be a requirement in terms of setting up a factory which will supply materials to the number of warehouses. So in that case, it's a situation like one facility, that's a plant or a factory, which will produce the material, and based on the products, it will be delivered to the multiple warehouses. Similarly, in case of a warehouse situation, which will cater to the number of dealers in a particular region. So again, it will be a kind of one facility and multiple candidate, wherein that particular warehouse will supply material to the number of dealers which are located in that particular region. Or it may be a multiple facility, multiple candidate situation, wherein you have a multiple facilities that are available, and those particular facilities, they will provide material to the multiple locations. For example, in that case, it may be a kind of a situation where you have 4 different plants which can supply material to 10 different warehouses. Now the problem here, or the question here, it arises that which plant will supply material to which particular warehouse, because in that particular situation, from each plant to each warehouse, there will be a cost, there will be a distribution cost that will be involved. So the problem here will be then which plant will supply material to which we can say warehouse, so that the distribution cost will be minimum. So in that case, you may use a kind of a problem methodology that we call it as a transportation problem formulation. So maybe as a part of your module 1 wherein you have got an exposure to the different operation research technique, you might have worked on this kind of a problem wherein you have looked at allocating the different plants to the different warehouses in terms of the material movement is concerned. Maybe you have worked on the transportation problem formulation and to arrive at the solution that which plant will supply material to which warehouse based on whatever the distribution cost that is involved in the particular plant and warehouse combination is concerned. So whenever we are looking at such kind of a location planning problem, we can use a number of techniques. Of course, these are some of the techniques which we are going to discuss. Okay, so we will first look at one such technique that we call it as the factor rating method, or locating the facility based on the number of factors that are involved. So we have already discussed that whenever we are looking at a location decision, there are a number of factors that will be involved. Okay, and based on the rating of these factors, whichever location will get a higher rating, maybe we can select that particular location for setting up the factory. So as a part of this factor rating method, you have to first identify and list all the relevant factors which are involved in that particular location decision. Then you have to establish the relative importance of each factor. Okay, because each factor will have a certain relative importance. For example, if you are looking at the availability of raw material as a factor, so there will be number of locations which are suitable for the particular decision. So let's say one particular location, maybe it will have a good raw material that will be available. Maybe the other location will not have the particular raw material that will be available. So you can see that based on the availability of the material, you can have a relative importance of the different locations that you are looking at for setting up your particular facility. So in that case, you have to establish the relative importance of each factor, and then you have to rate these performance of the candidate in terms of the location using certain rating mechanism. And based on the total score that you get based on these location, you can decide and rank those particular locations based on the factor rating that you have created. And maybe based on the rating, you may select that particular location. Okay, so here is, let's say, an example, which is a garment manufacturer who is looking up at 5 alternative locations, and there are certain factors which are associated with setting up of this garment manufacturing facility. So let's say these are the 5 factors. These are the factors. So there are 1, 2, 3, 4, 5, and 6 factors. And here there are 5 locations. And out of these locations, we have to select the location for setting up the particular factory. So as a part of the factor rating method, what you have to do, you have to first identify what are the relevant factors which are associated with the particular facility location decision. For example, in this case, the 6 factors are availability of the infrastructure, then size of the market, industrial relations, climate, tax benefit and concession, availability of the cheap labor, and nearness to the port is concerned. So these are the 6 factors may be associated with this particular location decision, which is related with setting up of the garment factory is concerned. Now you have to create a rating system. Okay, so what you can do, you can decide that how much weightage you will give to the particular factor. So let's say you have used a scale of 0 to 100. And now based on this scale, you have to give a rating for each factor. That means how much weightage you will give. Which factor is more important than the other factor? For example, let's say if the 2 factors are concerned, if it requires a very high skilled labor, so in that case, availability of the high skilled labor may be more important than availability of the raw material or infrastructure is concerned. So based on the kind of requirement, you have to come up with the rating for this factor. So this rating is nothing but what? It is the weightage that you would like to give for each of the factor. So you may use any scale. For example, if you are using a scale of 0 to 100, you may give a higher weightage, let's say, to availability of the infrastructure. So if it is a kind of a capital intensive industry like a cement plant, or it may be a steel plant, wherein you are required in terms of a good infrastructure, in terms of the rail network is concerned, in terms of the electricity tariff is concerned, and uninterrupted electricity or the power is concerned. So if it is that kind of industry, maybe you can give some kind of a higher rating or higher weightage to that particular factor. So it's the relative rating or weightage that you have to consider, that for each factor, how much weightage you will consider. Maybe for a size of the market, you will give a relatively lower weightage. That means you will give maybe a 60. For the industrial relations climate, it may be a 50. For tax benefit and concessions are concerned, you are not expecting too much tax benefit. So that is the least priority concern or the factor is concerned. So you may give a weightage of 30 for that. Availability of the cheap labor is concerned, you will give a relatively low weightage to that. So depending on the type of industry, first you have to create how much weightage in terms of what rating that you will give or you will consider for the individual factor. And whatever locations that are concerned now, you will try to give a rating to the location for each factor. For example, let's say location 1 is concerned. So let's say it is Trichy. Let's say this may be Chennai. So based on the individual location, now you will give or you will try to rate those locations on again a 0 to 100 scale, and you will try to relate these particular factors. For example, if location 1, Trichy is concerned, the availability of infrastructure, okay, so there is not much infrastructure is available, so maybe you will give a rating of 20. As far as size of the market is concerned, it is having a moderate size, so you may give a rating of 30. As far as the tax benefit is concerned, let's say you will get a good tax benefit, so maybe you will give a rating of 80. So based on the relative importance or relative advantage that you may get between all these locations, you have to give a rating to all these factors. Okay, so based on that, you are given a rating to all these factors for each of these locations, and then you have to estimate the overall rating for the location. So for that, first you have to establish the relative weight. That means you have to normalize the score. So how can you normalize it? You sum up all these particular rating that you have considered, and then for each of these, you try to establish the relative weight between all these 6 criteria or 6 factors that you have considered. For example, this will be 90 by 325. This will be 60 by 325, so on and so forth. So based on this, you are trying to look at that among the 6 particular factors are concerned, how much is or the weightage for the particular factor that you have considered. So these are the normalized weights that you will consider, and then for each factor, then you will multiply it. For example, the location factor you have given, location 1, you have given an availability of infrastructure as 20. So you will multiply it with the relative weight. You will multiply it for all the factors, and based on that, you will come up with the total score. So let's say for this, it gets to this value. Similarly, you will have to evaluate it for all. So you will have to multiply it, and based on that, you have to come up with the score, and maybe based on that, you will come up with all these scores, and based on that, whichever will give you the higher score, maybe you can select that particular facility. So as far as this particular factors and the location is concerned, using the factor rating method, you can see that you have rated all these particular locations, 5 locations, and maybe based on that, this particular location, which is coming up with the higher value of the rating, you may select this particular location as far as locating the facility is concerned. So this is what is about the factor rating method is concerned. I hope this is clear. Is it clear? Any doubt related to this? Okay, fine. So this was about the factor rating method. There are other methods which will take into account the relative positions where the particular facility is located. So one such approach that we call it as a center of gravity method. So let's say we are locating the different warehouses, okay, and for each warehouse there is a demand in terms of the material movement. So each location will have certain demand, certain load that the particular facility it has to serve, and based on that particular weight or the load, we can identify where the single facility that can be located based on the center of gravity at the particular number of other locations they are concerned. So this particular center of gravity is based on the criteria of minimizing the Euclidean distance between these particular facilities are concerned. So let's say we have a number of warehouses which are located, and based on that we want to locate a factory. So it's a single facility location decision. So it's a single facility location decision. So where you have number of demand points, that means the warehouses are concerned, and each demand point will have a requirement in terms of certain quantity that needs to be fulfilled. Okay, so all these locations of the warehouse we can identify in terms of some Cartesian coordinate, and then based on that we can have the coordinates for all these locations. So let's say this is warehouse 1, this is warehouse 2, this is warehouse 3, this is warehouse 4, this is warehouse 5, and maybe based on that location we will try to look at creating a new facility, that is the plant, which will fulfill the requirement of all these warehouse demands is concerned. So the coordinates of this new facility we can try to locate on this entire grid, and these coordinates, they are estimated based on this particular model, and this model is based on the criteria of minimizing the Euclidean distance that is involved in this particular different demand points or different demand centers are concerned. So it's the summation of xi multiplied by the wi divided by summation wi. So wi here is nothing but what? It's the kind of demand or the supply requirement. So for example, if it is a warehouse, how much demand is involved in that particular warehouse? If it is a kind of a location in the factory is concerned, and if it is a material movement, so the load will be or the weight will be in terms of the number of trips of the material handling device is concerned. So considering these particular weight, you can arrive at the center of gravity, that means the location of this particular new facility in terms of the x and y coordinates of that particular facility is concerned. So for x coordinate, it's the summation of xi multiplied by wi divided by summation of weights, and the coordinates of the y facility, coordinates of the facility in terms of the y coordinate will be summation of yi multiplied by wi multiplied by or this divided by the summation of the weights are concerned. So utilizing these models, you can locate the location of the new facility, which is nothing but it's at the center of gravity. Okay, so we'll look at one example, and maybe based on that, how we can utilize this particular model that we can see. So this is the same example that I have considered from the textbook for demonstrating you that how we can establish the coordinates of the center of gravity. So for example, there are 4 warehouses. Let's say A, B, C, D. It represents the warehouses, and we need to locate the factory at based on the center of gravity technique. So A, B, C, D, let's say it represents the warehouses. And the weight is in terms of, let's say, the demand that exists. For example, this factory has to supply 200 to the warehouse A, 450 to warehouse B, 175 to warehouse C, and 350 to warehouse D. So this is nothing but this is the weight, or we can say the load that it exists on that particular warehouse. And these are now the coordinates. So whatever the locations, if we consider them in terms of the Cartesian coordinate system, if we consider their position in terms of the Cartesian coordinate system, we can see that we have an X and Y coordinate for it. So let's say the coordinates of these 4 warehouses are X and Y. It is 125 and 550, 350 and 400. So we have the coordinates of all these, let's say, locations. That means warehouses is concerned. And now we have to look at a decision that where we should locate the factory. So that means we have to find the coordinates of this factory in terms of X and Y coordinate. So as per the model, it will be summation of xi wi. If we look at the model, it will be xi into wi
divided
by the summation of the weights.
Can we restart the Excel, sir, if you don't mind?
Okay, so using this particular model, then you can find the summation. That means you have to multiply the X coordinate with the weight, take its summation, and then you have to take the summation of the weights. So you can use it using the sum product function. We have already discussed about the use of the sum product function. So it's a sum product of, so how can you do it? I'll show it here, how this value has come. It will be sum product of which values? These particular x values with the weights. So this is nothing but it's the summation of x into w divided by sum of the weights. So I can use the sum function. So we can see that based on this x value and based on, similarly, we can utilize it for the y coordinates also. Okay, so you can get the coordinates of the new facility, and of course these coordinates will be in terms of the center of gravity of these locations. So if you want to represent it, maybe you can plot this with a scatter plot on this particular graph. So you can see that these are the 4 warehouses which will have a requirement in terms of the demand fulfillment, that is 200 at A, 450 at B, 175 at C, and 350 at D. And if you want to take a decision maybe of locating the factory based on minimizing the squared Euclidean distance, which is used as a part of the center of gravity method, you will find that you will locate the factory at this particular location, whose coordinates will be in terms of x and y, that is 430 and 354 for this particular factory is concerned. So this is the way we can use it for the location of a single facility. So this is based on minimizing the squared Euclidean distance. In some other situation, the movement may be in terms of the rectilinear distance. Okay, so as I mentioned that in any factory, if we are locating up a decision, maybe let's say it's a big factory is concerned, and if you are looking at locating the fire station is concerned. So maybe in that particular situation, it may be a kind of a movement that will occur in a rectilinear distance. So in such situation where the movement or the distance has to be measured in terms of a rectilinear fashion. So if we are looking up at the single facility location, so how we can locate it? So what you have to do is, if it is in terms of the rectilinear distance, so whatever the center of gravity method is concerned, that method is based on locating the factory, which is based on minimizing the squared Euclidean distance is concerned. So as far as this example is concerned, so let's say we have 6 plants, and if we locate these plant in terms of the coordinates on a Cartesian system, and for each plant there is a weight in terms of the load that is involved for this particular plant is concerned. So where we should locate the new facility or the single facility which will serve all these facilities are concerned. So what you have to do, you have to arrange these particular facilities in terms of the ascending order of the particular x coordinates are concerned. Okay, so we have arranged these particular location in terms of the values of the x coordinate is concerned. So you have to arrange it in the ascending order. So based on that, you have to find the summation of all the weights. Okay, so these are the weights, and then I have taken a cumulative weight of it, so that the new facility location X coordinate will be based on the median point. That means whatever value that you have obtained, that is the 7,700 is concerned, if you divide it by 2, you will get the median point 3850, and whichever point that is occurring, for example, this 3850 will lie between 3,000 and 5,000 here. So we will locate it at the higher point. That means this will become the X coordinate. Similarly, for Y coordinate, what you have to do? You have to arrange those in an ascending order of the Y coordinate. So this is for So this is for the Y coordinate. So similarly, you have to arrange the facilities in the ascending order of the Y values. So for example, if you arrange it in an ascending order, you will see that the sequence will be in terms of 6, 1, 2, 5, 3, 4. So you have to arrange it in an ascending order, and again you have to find the cumulative weight. That means you have to locate the median point. So as far as the median point value is concerned, again it gets to 3850. And now if you look at these point where it appears between 3,100 and 4,900. And since 3850, we will look at the higher value, which is nothing but which will be close to 4900. So the Y coordinate will become 300 and 300. So for the new facility, based on this rectilinear distance criteria, the new facilities X and Y coordinate can get to 300 and 300. So in this case, it may become a new location that you will be locating, or sometimes you will see that whatever the existing facilities that you have, one of the existing facility will become the new facility wherein you will locate the particular facility that you want to locate. So this is about the single facility location decision is concerned. So this is for Y coordinate and this is for.
So always we should consider the higher value only, not the nearest value.
Yes, on the higher side.
Okay.
Shall we close and open it again, because I changed the options?
Whatever you do it. Yeah. Is this clear? Any doubt related to this? Okay.
Sir, only one doubt. The weight that you're talking of, if we have to make our own weight calculation, how do we do that in terms of making the tabulation for that graphs?
Which one? This one?
Share. Haven't shared it. Share it.
Sir, we are not able to see your screen.
Yeah, I'm sharing the screen. So in the first method,
The W, sir.
these weights.
Yes.
These weights are nothing but it may be a kind of a demand or it may be a kind of supply. Okay, for example, if it is a kind of a supply situation wherein you are looking at number of trips from that particular supply location to, so for example, if it is a distribution center, in that case, it may be the number of trips. So what kind of weight or load that exists on that particular facility. If it is a warehouse, it will be in terms of the demand that will exist from the plant. So for example, if there are 4 warehouses and you are looking up at setting up a factory or a plant which will supply or which will fulfill the demands of these 4 warehouses. So in that particular situation where you should locate the factory that will fulfill the demands of all these particular warehouses are concerned. So this weight is nothing but it's maybe either a demand or it may be either a supply.
It's a value that we give based on weightage that we give for our demand and supply. There's no calculation for it, right? If we have more demand, the value we'll need to give is 500, 400, 300. It's a relative measurement that we need to give, or do we have some calculation to do that, or any basis for creating the tabulation for weight?
No, this is not the weight or the rating that you are giving. Okay, this is the actual load if you consider maybe on that particular facility.
Load in the sense, say you said trips. So per day I have 50 trips to say Kanjipuram location from one location. So another location I have 20 trips. So should I put 50 and 20 out there?
Yeah. So for example, if you have a demand in terms of, let's say 1,000 units at a particular warehouse, okay, and if that material is being transported using a truck and each truck can accommodate 50 units. So in terms of the load, how much it will be? It will be 20 trips to that particular warehouse.
Okay. So we put the trip 20 over there, not the 50, right? 20 is the weight.
So that's kind of a weight. So how do you estimate or how do you measure that load? It depends. So the load may be in terms of the demand, the load may be in terms of the number of trips. And based on that, you are trying to locate the new facility.
Okay, sir. Right.
Okay, any other doubt if the things are not clear? I know because of this tab issue, if I'm not able to write many things because many times it's getting in a hang position. So maybe you will be facing some difficulty in understanding. But then if you have any doubt, you can ask. Okay. Okay, another situation can be like we have 4 existing supply points and for that we have 4 different candidates from which we can get the supply from these particular. So let's say there are 4 warehouses which are existing, and for each 4 warehouses, there is a requirement in terms of the load that is considered. But now there are 4 proposed locations. Okay, so let's say there are 4 locations, and out of these 4 locations, we have to select 1 location. Okay, so let's say for meeting the requirement of these particular 4 warehouses, let's say we have 4 different locations. So in earlier case, we have located the plant maybe at the center of gravity. So it's a single facility location decision that we have considered. Now let's say we have 4 possible locations. So these are the 4 possible locations. And out of these 4 locations, we have to select 1 location. So in such situation, we can use this load distance method, wherein we will try to locate the factory based on the estimation of the total load that it exists in terms of the load and the distance criteria is concerned. And the distance we will measure in terms of, so this distance we will measure in terms of the Euclidean distance. So it's nothing but x minus x whole square plus y minus y whole square. And then based on the individual distances, the summation of dij and the individual weight, we will try to find the load distance, and based on the minimum value of the load distance, we can select that particular location as the location for the new facility. So here we have alternatives are available, and we have to come up with one alternative which will meet the requirement in terms of the minimum load that is concerned. So for example, here now we have to estimate the distance between each of the facility based on this criteria, based on the Euclidean distance measurement is concerned. So distance D is equal to x minus x1 square plus y minus y1 square. And this is nothing but it's a Euclidean distance measurement. So it's nothing but it's a Euclidean distance for each of these particular supply point and the particular candidate is concerned. You have to find the distance. For example, between A and 1. So the coordinates of A are x 125, y 550, and coordinates of location 1 is 300 and 500. So we have to establish the distance between these two using this measure. So you can use this particular cell formula, and based on that you can establish it. So for example, here it's the square root of this x minus x1, and its square is required. So x minus x1 square plus okay, so in this way you will establish the distance between these, and then you will have to take the summation of the load distance. Okay, so that means from this particular to this particular, how much is the total load that is concerned in terms of the load distance. So you have to establish the load distance. So for each location, you will locate the load distance. For example, for location 1, the total load distance is nothing but it is equal to these particular values, these particular weights multiplied by these values. So it's a sum product, and the total it gets to this value. So for each location, so these are nothing but location. So for each location, you have to establish the load distance, which is nothing but weight multiplied by the distance. And based on whichever location will give you the minimum value, that particular location will be selected as the location for the particular facility is concerned. Okay, so this is about the load distance method that you can utilize for locating the facility, wherein you have multiple locations are available, and out of which we have to select one location for locating the facility. Is it clear? If any doubt, you can ask.
So if we use center of gravity method only and get the nearest answer, it will be same, sir?
Which one?
If we use the center of gravity method only, using this, and then we will cross verify with the proposed facility, which is the nearest one, like that we can analyze and solve, sir. Both will give the same solution.
No, these are the few options that are available that you have identified. Okay.
Yes,
these are the few options.
Yes, sir. Options are available.
So it will
like
not match with the center of gravity. Definitely, it will not match with the center of gravity.
But nearest one will give the same answers, no, sir. It won't give.
Maybe you can try. Okay. But then what criteria that you have used for identifying the location, that will be different, isn't it? For example, these 4 locations may be based on the availability of the cheaper land only. Okay, so you have identified 4 locations where you have some kind of a cheaper land is available, or maybe it's a situation that as a part of the trade promotion, government may have given you a land on lease at a very cheaper rate, and now out of these, now you are trying to establish that which particular location, or out of these 4 locations, which you will select.
Yes, sir, that's correct, sir.
So
I'm saying that to get get the solution fast, if is gravity, and that result when we get it, if we compare with this proposed facility available, so if we compare which is the x and y nearest value.
Yeah, you can do that. You can do that.
It's a fast solution.
Yeah, you can do that. Okay, this approach is based on when you have few options, and out of those you have to select one.
Okay, sir.
Okay, yeah. Okay, so these were some of the techniques which we can utilize maybe based on the location decision. Okay, another situation that we have looked at is the transportation problem. Okay, so you have already gone through the course on the operation research, wherein you might have worked on the transportation problem. So in this case, when we are looking up at what kind of combination for a particular warehouse to a particular market in this situation, that which warehouse should supply a material to which market region. So based on that decision, we can use the transportation model to arrive at that which warehouse should supply material to which market. Or in other situation, if we have multiple plants and you have a multiple warehouses, so which plant should supply material to which warehouse? So that particular kind of a distribution situation based on the location is concerned. So you can use the transportation model formulation and you can do that maybe based on that particular formulation is concerned. Another situation wherein you can come across the facility location decision is a kind of set covering problem. Okay, so it's a situation wherein a facility has to be located and that particular facility has to cover the entire region. For example, if there are 50 retailers are involved, 50 retail stations, retail locations are to be covered by a location of a dealer. Okay. Similarly, it may be a situation wherein you are looking at locating a fire station. So in a particular city, like let's say a metro city like a Bangalore or Chennai or Mumbai, wherein the local governing body, they are looking up at locating a fire station so that a particular region has to be covered by the particular location of the facility. Similarly, in case of an emergency location, like a location of the healthcare center or the medical facility is concerned, or it may be a situation where any big bank, they are looking up of setting up their bank branch, or if it may be a kind of situation where you are looking up at locating the school. Okay, so that particular location has to cover the entire set which are required to be served by that particular facility. For example, if it is a bank branch, then whatever the nearest location that it has to cover or it has to serve, maybe the location decision will be in terms of the coverage that the particular bank branch has to give in the nearby locations, or the dealer which has to fulfill the requirements of all the retailers in that particular region, or if it is a school which will require, which will serve the requirement of the particular region in terms of the transportation using the bus facility is concerned. So all these kind of a situation where you are looking up of setting up a location or setting up a factory or setting up a facility which will fulfill the requirements of the locations or the particular region is concerned. So that category of problem is called a set covering problem, wherein you are looking up of setting up a facility which will fulfill the requirement of, or it will fulfill a set of all the nearby region. So that kind of problem is called a set covering problem. Okay. Can you give me any example wherein you can locate or you will come across this particular decision? Can you think of any situation where it will involve a kind of set covering problem?
Fire station, sir.
Fire extinguisher, of course.
Courier office.
Emergency situation, then?
All the police station.
It may be a police station. So for a metro city or for a bigger city, they will have a local police station which will cover the some limited community in which the city is being divided. Okay, so that type of problem wherein we are looking up at locating the facility will be a part of set covering problem. Okay, so let's look at this example where we are looking up at setting up a fire station. So this problem is related to a city wherein they are looking up at setting up the fire station. Okay, so the city is divided into 8 different regions. So let's say the situation is like it's a so the entire city is divided into different regions. And we need to locate the fire station so that it will serve all these regions. So how many and where you should locate the fire station so that it will reach to any particular fire event within certain stipulated time. So let's say here the response time is considered to be 10 minutes. Okay. So in this particular situation, they are looking up at setting up a fire station so that wherever a fire event occurs or wherever a fire occurs, the fire van should reach to the location within 10 minutes. So this is what is the situation. And now the objective is to determine which, now these are all, let's say, the tracks in which the city is divided. So the problem here is to determine which track should receive a fire station. That means in which track you should locate the fire station so that if any fire occurs in any region, so let's say here if it is a fire, it occurs, it should reach in 10 minutes. So how many such fire stations that you need to locate, and in what location you will locate the particular fire station. So the objective is to determine which track will receive a fire station to minimize the total cost, because for locating the fire station, you will incur a cost. And depending on the availability of the land and maybe the availability of the resources is concerned, each fire station will involve a different cost. So the objective is to minimize the cost, but at the same time, it should serve the purpose of covering this entire set with the number of fire stations that you will create based on this particular situation or this particular requirement. Okay, so we will look at this. So it's a kind of a situation where we are again looking at the facility location, and this type of problem you may solve it using an operation research technique. Maybe you might have learnt in the operation research module the binary integer programming. So here it's the we can see that these are the points at which, so let's say the city is divided into a number of tracts or the area or the region, and this represents the distance. So whatever here it is mentioned, it represents the distance if the fire station is located at region 1. So let's say if this is region 1. So if the fire station is located in region 1, and if the fire occurs in region 1, it will take 2 minutes to reach to the fire. Similarly, if fire station is located in region 1, and if the fire occurs in region 2, it will take 9 minutes to reach to the fire. Similarly, in this way, if the fire station is located in this particular 8 tracks that have been identified, and if the fire occurs in a particular track, in how much time you can reach to the particular fire location, this data is mentioned here in this particular table. Okay. For example, if the fire location is located in tract 8, and if fire occurs in tract 1, it will take 28 minutes to reach to the fire. And the requirement is that the fire station has to be located in a tract such that if any fire occurs, it should reach within 10 minutes. Okay. And for location of the each tract fire station, there is a cost that is associated. So here is the cost that is being given. For example, to locate a fire station in tract 1, it will cost 350. To locate a cost in locate a fire station in cost in tract 2, it will take 250. So based on this requirement, we can formulate it as a binary integer programming problem. So the decision here is in which tract we should locate the particular fire station. Okay, so that if fire occurs in any of the tract, it should reach within 10 minutes. Okay, so we can decide that which possible tract can receive the fire station. For example, here the distance is 2 minutes, so we can locate the tract here. Here the distance is 8 minutes. We can locate the tract here. The distance here is 18 minutes. We cannot locate the fire station here. So based on that response time that is involved, okay, you may decide whether the fire station can be located or not. So it's a yes/no decision. So you can utilize this if statement, and based on the value that it exists, if it is less than or equal to the response time, you may have a yes decision. If it is greater than 10, you can have a no decision. So based on that, you can create a matrix in terms of the response time, whether the fire station can be located or not. And whenever the fire station is located, how many areas it is covering, because each track has to be covered by at least one fire station. Okay, so how many fire station will cover, that requirement you have to fulfill. So this is what is the constraint. So this is what is the constraint, and based on this constraint, you can formulate it as an optimization problem utilizing this binary integer programming. And this is the decision variable that which tract or should receive the fire station. And this is what is the objective function. So the objective function is nothing but what? Which tract will receive and the associated cost in that. So it will be a sum product function of the cost of the station and whether the fire station is located in that particular tract or not. Okay, so the objective here is to minimize this cost based on this particular constraint, that if the fire station is located, that should be covered by at least one particular fire station. So if fire occurs, it should be served by at least one particular fire station that is involved. So if you solve this model using the solver, with the objective of minimizing the total cost with the changing sale as where you will locate the fire station, and with the constraint that the number covering should be greater than 1. If you solve it using the solver, you can see that you will get a solution, and you will see that the fire station is located in track 2, in track 7, and in track 8. So you can see that the facility or the tract or the fire station is located in these 3 locations. And you can see that if the fire station is located in tract 3, tract 2, it will serve these 3 locations. It is located in 7, it will serve these 2 locations and these locations. And if it is in 8, it will serve this location. So you can see that based on this solution of 3 fire station in these 3 particular tracks, track number 2, track number 7, and track number 8, you can see that all the locations in that particular region, they are covered, which is within the 10 minutes. So this is also one of the approach which we can utilize in a situation where we are locating a facility and the requirement is a kind of set covering problem wherein that particular facility should serve the entire region which is located, and this type of problem can be formulated as a set covering problem, and maybe based on that we can find the solution. Is it clear? Okay, so this was about the facility location problem, the requirement in terms of what factors which we need to consider when we are looking up at a facility location decision. And based on that, we have used some of the techniques which can be utilized. Of course, there are many other techniques like the min-max technique, wherein you are looking at minimizing the maximum distance that the facility has to serve for the requirement. And of course, there are many other techniques because it's a kind of an optimization problem. So there are many techniques can be utilized, but I hope you have got the glimpse or the exposure of what do we understand by a facility location problem, and maybe based on that, we have discussed about some of the techniques. So if any doubt or anything which you want to relate it maybe with these particular concepts, you can ask. And otherwise, we will look at the case that I have already shared with you. So this is the case which is related with the facility location problem. I hope all of you have gone through this case. That is on Summit Maritime, the facility location and layout design problem.
Yes, sir.
Okay. So this is the case about the facility location for a boat manufacturing facility. Okay. So can anyone just summarize what are your observations based on the reading of the case? So we will require another at least 20-30 minutes to look at this case, and maybe based on the case discussion, we will stop for our session for the today. So what kind of problem the Mr. Joseph is facing as far as these operations are concerned? Because here you have to relate whatever the concepts that we have discussed related to this real life situation.
He is not able to attend all the location.
This company is having a business office in the center of the city. However, their manufacturing facilities are far away from the their business office. One facility they are making a premium boats. Another facility they are making a commodity boats. Okay. So the operations manager there was a very keen to take care of the production part by himself. So he has to travel a lot along with his team to both of the manufacturing locations where it takes a lot of time. However, both of the manufacturing locations are situated in a location which is suitable earlier, but now one facility is on lease which is about to expire, and they are planning to increase the rent also. Another facility which they acquired from the another party were having in a good location, but it is still far away from the their business office. Now they are exploring to look for the common facility for production as well as for the business office in a near to the city highway NH96, somewhere near to this highway. and they came to know that all of a sudden this the location where their current business office is there is going to be a very prime location for the city. So whether he has to skip his current business location, number one, and if they have to initiate another manufacturing location, where they have to put it, it has to be near to the NH highway, or they have to select any of these two manufacturing location in a continuous manner.
So this Sumit Maritime, basically they have two production facilities. Okay, the one facility, and it's a case which is given based on the location at Kochi in Kerala. So they have two production facilities. And one consulting office. So they have two manufacturing facilities at A and B. So as far as the case is concerned, the consulting office is at A. So it had two production facilities and a consulting office. The consulting office, that is facility A, is a centrally located facility in the downtown area, and it's next to the city's central road transport hub. Okay. And facility B, which manufactures the premium boats. So this facility B, it manufactures premium boats. It is located on the Wellington Island, which is the largest artificial island, and the facility B is required to produce two small boats and one medium or large boats. Okay, so the problem here is that there is a lot of movement between all these facilities, because they have a consulting office at A, and they have two manufacturing facilities, and then because of the rent that is increased. So if you look at page number 3, so the manager, he has to take the clients to the facilities B and C to view the boats. Okay, so it's a premium segment kind of a boats. So whenever any client client comes, first they have to attend the client at their consulting office, which is at facility A, and then that particular client has to be taken to the facility B and the new facility, that is the what is the name of that? It is Arya Marine. So the Sumit Maritime, they have taken over one company, that is the Arya Marine. So that they call it as the facility C. So this. So whenever the client visits for the purchase of any boat, first they have to demonstrate, and they have to what you can say, discuss about the boats and their requirement at the consulting office, and from there then the client is to be taken to the boat manufacturing facility, that is at facility B and facility C. So it requires a lot of traveling time. Similarly, their office staff, their technical staff, they all sits at the consulting office, and for the manufacturing related activities, their staff, they also have to move from the consulting office to the manufacturing facilities. So they are looking at their facility, which is at B, because the rent is now increased, okay, and he is not looking at, or he is not considering that rent to be, and they are looking at a new facility. So they have consulted the real estate agent, and the real estate agent has come up with the 5 locations. Okay, so you can see that there are 5 locations which are given in the at the end of this particular case, which is in Exhibit 2. So Exhibit 1, if you go to page number 6, it shows the entire locations of the different facilities. So you can see that the consulting office, which is facility A, is located at the Vitila hub, and the manufacturing facility, which is B and now the C, they are located in one in Wellington Island, and second one is at the other location. And in Exhibit 2, you can see that the distance in terms of the number of trips between the facilities is given. So if you look at Exhibit 2, the upper triangular matrix, that is A to B, is 30 trips, A to C is 12 trips, and facility A is nothing but it's a consulting office, and B and C, they are the manufacturing facilities. So from A to B, there are 30 trips. So that is nothing but it's a load or the weight that we have considered in the facility location problem. Okay, so there are 12 trips from A to C, and from B to C there are 18 trips, and the distance is also given in terms of the movement between the facilities ABC and the new locations or the proposed locations, which are X1, X2, X3, X4, X5. So X1, X2, X3, X4 and X5, these are the proposed location for which facility? It is facility B, because the manufacturing facility B, it was on lease and the rent is increased. So he is looking for a new location. So these are the 5 potential locations which are available. Okay, so in Exhibit 2, we have given the data in terms of the distance between each location or the combination of location. What about Exhibit number 3? So in Exhibit 3, the management, they have identified 4 factors. Okay, so these 4 factors are proximity to the downtown area, clustered along the national highway, effective utilization of the available space, and unit pricing of the floor space. So whatever we have discussed in the factor rating method, that we have to identify the factors. So these are the 4 factors they have identified, and the weight that is considered for each factor. So for example, here for proximity to downtown area, they have considered a weight of or weightage of 35. For second factor, they have considered the weightage of 25. For third factor, they have considered the weightage of 15, and for fourth factor, they have considered the weightage of 25. So this is being given in the exhibit number 3. In exhibit 4, the space consideration for the different shops that need to be created in that particular facility. Okay, so they are looking at service factory. What do you mean by service factory? I hope all of you have gone through the case, so you can understand these terms and concept.
Some part of the operation, not total operation, but some of the some of the scope that will be covered.
So a service factory is a kind of a factory wherein you will have a kind of a display area, wherein you can have a kind of a business transaction, and at the same time you will have the manufacturing operations as well. Okay, so this is what is the kind of or the meaning of a service factory here. So they are looking for the service factory. So they have a requirement in terms of the office space. They have a requirement in terms of the display space and the manufacturing operations as far as the boat manufacturing is concerned. So they are expecting that at a time they can manufacture, or the production facility will need to manufacture 2 small boats and 1 medium or the large boat. And for each of these, the area is given. For example, office space for the client engagement, they require 1 office space and it requires 150 square feet of the space. For construction area for small boats, that is manufacturing, they require 2 areas because 2 small boats need to be manufactured. The area is in terms of 20 feet by 8 feet, that is 160 square feet the area required. For a medium boat, it's 28 by 12. For a large size boat, it's 35 by 15. But at a time, either a medium or a large boat is manufactured. Then display area, they require 525 square feet. For tool room, they require 100 square feet. And for worker, restroom and amenities, they require 160 square feet. Okay. And what kind of layout it will be? For a boat manufacturing, it's a fixed position kind of a layout. So the boat will be kept at one place and all the manufacturing resources that they need to be brought near the boat so that the boat can be manufactured. Okay. So this was about exhibit 4. In exhibit 5, the locations are given. And what about exhibit number 6? In exhibit 6, the floor size of all these new facility or this potential location is given. For example, for X1, the size available is 70 feet by 40 feet. For X2, it is 6,000 square feet of space is available. For X3, it is 2,100 square feet is available. Similarly, for each, the monthly rental fee is given, and the distance from the NH66 is also given here. So this is the data that is given. And now based on the facility location problem or facility location techniques that we have discussed, we have to decide that Mr. Joseph should select which location out of these 5 locations are concerned. Okay. Is there anything that is not included as a part of the explanation or the discussion is concerned? If any point is missed out. So now what is the problem here? Problem is to select
best
the
location
and decide the block plan as far as the layout is concerned. Okay, so first we will look at the location decision. So we have studied or we have discussed different techniques. So what is your comment on that now? Which technique you can utilize? If all of you can turn on your videos,
load
we can have
distance
a better
method.
interaction.
Load distance method.
Transportation problem we can apply.
Central gravity method.
Transportation problem.
Okay. What about based on the factors and their weightage is given?
we can use center of gravity or transportation. Load distance method is not applicable, I think, here. Best one is center of gravity or transportation.
So
Because
based on
multiple
the data that is being given, you have to look at which technique you can apply. So for a center of gravity, what you need?
Weightage given, locations also given.
Station coordinates.
What about factor rating method?
So weightage of each operation is given. No?
Yeah, factor rating also we can apply.
Okay, so all the data is given from the exhibit. For calculation purpose, I have extracted some of the data from these sheets to the Excel sheet. Okay, so which method you can apply? The load distance method?
Yeah, we can use load distance also.
Okay, so how will you decide the load and the distance? So what is the load here? What is the load?
Number of trips.
The load is in terms of number of trips, because whenever any client he visits for the boat purchasing, first he has to be attended at the consulting office, and from there the client has to be taken to the manufacturing facility, which is located at B and C. So facility C is a Arya Marine, which is being taken over by Sumit Maritime, where small boats are manufactured, and it's a waterside area. So all that description is given. You can go through it once again. I'm just trying to bring the issues, that how the real life situation we can relate it with the models and the topics that we have discussed. Okay, so the load is in terms of the number of trips. How will you estimate the distance? So the distance is given in terms of the kilometer from exhibit 2.
Given in terms of kilometers.
Yes, yes. So as far as the X1 location is concerned, okay, so what will be the distance? It will be 9.9. Okay, because the new location X will replace location B. If you look at the exhibit number 3A2, where you are where the company is looking for locating the new facility, in one of these X location,
yes,
and this X location will replace which facility? It will replace facility B.
Yeah.
Okay, so what will be the distance between A to X?
X is 9.9 into.
Distance is AX. Huh?
No.
So what will be the distance between A and new facility? So AX1.
9.9 into 30.
9.9 into 30.
No, first you come up with the distance matrix.
Yeah.
So this is the distance matrix.
Yeah.
This is what? This is the load. Okay. So what will be the distance between AX1? It's 9.9. Okay. You have to refer to table number, exhibit number 2. So all these distances are given. Okay, so the distance is now known, and now we can estimate the load distance. Okay, so the load distance between AX1, so it will be 9.9 into 30, because the load here is 30. Similarly, for each point, we have to estimate the load distance. Okay, and for each load, for each location, you have to estimate the load distance value here. So the total load distance for this particular X1 location here is, you can see, 608.4. I hope this first table is clear to all. The distance matrix. Okay. And this is now the load distance matrix. So this is what is the load. So this you have to multiply it for the distance. So this will create the load distance. So what is the total load distance for location X1? It is 608.4. So you have to sum it up. And which will be the decision, or which will be the location that you will select, which will result in the minimum load distance. So the minimum load distance location is
X3.
Location X3. So location X3 will be selected. Okay. What is the size of that location? It is 60 by 35 feet. So based on the load distance method, you can select the location X3. You can also use the factor rating method. For that, you will have to use the extrapolation principle. Okay, because if you look at the exhibit number 3, just go through the note that is given at the below the table. The factor
scores a new facility drop linearly with the deviation from best choice 100%. And the total range of distance 2000 to 2400 square feet, 185 to 200 square meter in annual rental budget, new facility of $120,000. So the top limit. So they've given the amount for the new facilities.
Okay. So for this, what we will do, we will use the extrapolation, and for this, for extrapolation, this condition is given that a 10-kilometer cutoff boundary may be used. Okay.
Yes,
so
yes.
For extrapolation, if the location is beyond 10, we can give a 0 score. And if the location is, that means what? We have to find the two parameters, one which we can give the 0 score and one which we can give the 100 score. So if you consider this particular factor, okay, and if you go to exhibit number Exhibit number 6. Okay, so the distance, if you look at the last column, the distance of each location from the National Highway 66 is given. Okay, so in that, which is the lowest distance? It is 0.1 kilometer. Okay, so if you are looking at this particular factor, that how these locations are clustered along the national highway, we can say that a 0.1 kilometer will receive a score of 100. And since for extrapolation, the maximum distance is mentioned as 10 kilometer, we will say that whatever distance which is 10 kilometer and beyond, we will give a score of 0. Okay, and now based on this scale that we have considered, whatever the individual distances that it exists, we can give a rating to that. Okay, for example, if we look at the location of the X1, what is the distance from National Highway?
It is 7 kilometers, so 70% we can give.
It is 7 kilometers. Okay, so we will have to extrapolate it to arrive at the rating value. So here we are calculating the rating. So as a part of the factor rating method, the first thing is that you have to decide the weightage for the individual factor. And then for each location, you have to create a rating. Okay, so either you may use your own judgment, or maybe you can use some expert judgment and give some weightage to the individual factor. So the way it is given 35, 15, 20. So maybe you can use some scale, and maybe based on that, you can give the weightage. But since here, the factors, they are in some quantitative measure. For example, 7 kilometer, how you will give the rating for 7 kilometer? Similarly, for X2, the distance is 10 kilometer. How you will give the rating for 10 kilometer? So for that, you have to decide the scale based on the 0 and the 100 value, and then the individual value where it lies, you can extrapolate it between these two values. Okay, so how can you extrapolate it? So let's say 0 is given a score of 100. 10 kilometer is given a score of 0.1 is given a score of 100. We are looking at this particular factor. Huh? How we should give the rating for this. So 0.1 is given 100. So this is what is the scale that we have considered based on the data. That for clustering, we are considering 0.1 as the 100 kilometer, 0.1 kilometer as 100, and 10 kilometer as 0 square. Similarly, for other factor based on the data that I will explain. And based on that, we are come up with this factor. So these are nothing but what? Rating to location. So how will arrive it? 0.1 is given 100 rating, 10 is given 0, and we are now want to give what rating should be given to the distance of 7. So let's say 7, it lies here in between these two, and let's say for 7 the value is x. So let's say this is the value that we want to find out. Let's say it is y. So we are extrapolating it between these two values. So maybe you can use any of the scale. So it may be 0 minus 100 divided by 10 minus 0.1. This will be equal to y minus 100 divided by 7 minus 0.1. Is it clear? This is called the extrapolation. So whatever the range that we have, based on that, we are trying to extrapolate what can be the value. Because for 7 kilometers, how will you decide what can be the rating for a 7 kilometer distance? So this value we are coming based on, or we are trying to get it based on extrapolation. So if you simplify it, it will become 7 minus 0.1 upon 10 minus 0.1 to 0 minus 100. And when y this will come, so this y will be equal to then so this y will be equal to then 100 plus this value. Okay. I hope it's a rearrangement of the term, and based on that, if you calculate it,
30.3.
How much it gets?
30.3.
30.3. So this is what is the rating. So similarly, you will do it for the other one. For example, for second location X2, the distance is 10 kilometers. What will be the rating? We have already established the scale. 10 kilometer and above, it will get a rating of 0. Okay, so second factor will get a rating of 0. X3, it's 0.1 based on the data.
100.
So the location of X3 is where it is at 0.1 kilometer. So that will get a score of 100. Then X4, what is the distance? It is
0.5.
0.5 kilometers. So again, you will use the extrapolation. So for X4, this will be 0.5. For that, we want to find the rating. So again, you will using this type of formula, you will extrapolate it and you will find the distance, find the rating. So if you use this extrapolation, you will get a score of 95.96. Okay. And similarly for X5, which is 0.7 kilometer, you can get a rating based on extrapolation. Okay. Similarly, for other factors, you have to find the first, the ideal one and the worst one, that is 0 and 100. For example, proximity to downtown. First establish this criteria, which will be the best and which will be the worst. So in this case, it is mentioned that 10 kilometer will be the maximum value which we will use for extrapolation. So in this distance, 10 will get a 0 score. And if you look at the data, if you go to exhibit number 2, so as far as the proximity to downtown area is concerned, if you look at column 1, that is column A, this particular column, because this is what will represent the downtown area. So which is the lowest value or which is the best location is X3, which is having 3.4. So 3.4 we will consider as a score 100 and 10 kilometers as a score of 0. Okay. And now using this scale, for each of these distance, you will extrapolate it and you will find the score. So this is what is the rating for all these factors. Okay. Similarly, for effective utilization of space, if you look at the exhibit number 3, it is mentioned that the area should be the total space in the note. The total space required optimal range is between 2000 to 2400. Okay. So if we take the mean value of it, that is 2200, we can say that 2200, which is the mean value, as 100. Okay. And what will be the score of 0? It drops linearly. So for every 10%, it will drop by 220. So from 100 value of 2200, if it has to come to 0, what will be the rating or what will be the space? It is 4400. So 4400 of space will be given a rating of 0 and 2200 will be given a rating of 100. And now you have the space for area of each of the facility given in exhibit number 6. So if you go to exhibit 6, how much is the area for, is this clear that how we have taken the score of 0 and 100 for the space utilization criteria? It is given 2000 to 4000. So we have taken a mean. So 2200 we have taken it as a mean and that we have given as a score of 100. Okay. And now for 0, it will drop by 10%. That means 220. So for coming it to 0, it will need another 2200. So for 0, it will get to 4400. Okay. And what is the area of the X1 facility? It is 75 feet by 40. That means okay. So you have a scale now and you have an area. So you can extrapolate it. So based on that, we can see that we are getting these ratings. Okay. And similarly for the unit pricing, if you look at the table, exhibit number 6, how we can arrive at this value. So out of these, you can see that the lowest is 2.4. So that we can give it as a 100 rating. And the highest is 5. That we can give a rating of 0. So this is what is the rating for the pricing. And based on this, then you will extrapolate it. Okay, so for these values of the area, we have extrapolated it and got the rating here. And for these values of the unit pricing, based on the scores, we have extrapolated it and got the scores here. Okay. And now, based on the weightage that you have and the factors that you have, you can establish the factor rating. So this factor rating is nothing but what? It is the weightage multiplied by the factor. Okay. And if you sum it up, you will get the total weight. And based on this, which factor or which location is getting the higher rating?
Again, X3.
X3. So I hope you have got this, how this matrix has come. So this will be multiplication of this. And then summation. Similarly, this with this, this with this. So all these you have to sum up, multiply, and then sum it up. So this is nothing but the factor rating method. Is it clear? If anything is not clear here, you can ask. Okay, if this is clear, then we will stop our discussion for today's session here. Okay, so maybe you can go through it again, and then based on the discussion, you may try to relate it with the given data and with the requirement that is being considered as a part of real life situation, which is considered in this case. And maybe based on that, you can extend your understanding for the solution that we have tried to obtain. And based on that, if you have any doubt, then you can ask it either through an email. Okay, for this example, I will share the screenshot of this sheet so that you will try to understand the and relate it with the approach. And based on this, you will try to come up with your solution, and then you will compare it with the results that you are supposed to obtain. Okay, yes, Mr. Bal Subramanian.
For this exercise, whatever in the maritime, this will be given as a homework for us, or this you want us to make practice?
Which one? This case?
This one, yeah.
This is just a kind of real life application of whatever concept that we have discussed. Okay. So this is how whatever the models that we have discussed, how it relates with the real life situation based on the real life information, and then how we can obtain the solution based on the techniques that we have discussed.
Okay, sir. Thank you, sir. In the next session, there will be a quiz.
Yes. So that's what we wanted to discuss. Now, in next session, we will have a quiz.
Any coverage, sir, which one, whatever taken these two sessions, and any chapters to be referred in
based on these two sessions.
Contents.
Okay. I will announce the quiz instructions on the Google Classroom.
Okay.
Okay, then. So I hope you have understood this. You will practice it again, maybe based on again reading this case and trying to relate the concept with the models and the techniques that we have discussed. So we stop here for today's session. Okay. Thank you.